Hello everybody, welcome to this video. So in this video we are going to have a look at horizontal transition curve, how it is designed, what are the criteria for designing a horizontal curve, and why do we need horizontal curve. These are the things we'll be discussing in this. So to gradually change the direction of a road, horizontal transition curve is provided. See, what happens is when a vehicle is moving on a straight road, it is moving on a road with radius or radius of curve equal to infinity. So if we start the radius of curve to be a limited amount, maybe x, y, z, it happens so that the sudden jerk will cause the discomfort to the passenger. So that is what we have shown in this figure. Vehicle is moving on this straight road, and if transition curve is not provided in between from start of the curve to some distance, there would be sudden change of radius from infinity to R2, which will exert pressure or centrifugal force on the driver, which will cause discomfort to the driver. To avoid this, we provide a transition curve to gradually introduce the uh, XYZ radius, or maybe finite amount of radius. So at a straight section, radius of curve is infinity, and it gradually reduces to value of R of designed circular curve. As we have designed in the previous question, here we have found out the radius of curve as 229 meters. So if there is no transition curve, the radius will suddenly change from infinity to R, or maybe 229 meters. And if it suddenly changes from R to infinity to R, it will exert a value of WV square upon GR2 on the vehicle. That will be suddenly introduced to the vehicle, and that will cause discomfort to the passenger. In case of straight section, we also exert the movement of the vehicle is also exerting centrifugal force, but due to the radius being infinitesimally large, the centrifugal force comes out to be nearly zero. So this is the reason we need to provide transition curve. Now, what are the objectives of providing transition curve? It is to make sure that the centrifugal force on driver increases gradually, and hence it prevents discomfort to the passenger. Second point is to gradually introduce super elevation and extra widening. If uh, for a concept we understand that here the width of the pavement is this, and we need to increase the width of due to extra widening. So if we suddenly increase the width, it will be unaesthetic, and as well as it is not possible to increase the width of the pavement, and also super elevation is not provided suddenly. That is why we need to provide the transition curve for transitioning the vehicle from straight road to uh, horizontal curve. So this is to be noted. For an ideal transition curve, the length of curve should be inversely proportional to the radius. That is, L and R is constant. L dot R is constant, and L is inversely proportional to 1 upon R. As radius increases, the length decreases, and radius decreases, the length increases. See in this diagram also, the red portion is showing the transition curve. As R is decreasing, the length is increasing. See here, the R would be infinity. Here it will have a value less than infinity. This will be further reduced by from infinity, and as the radius in decreases, length of transition curve increases. Fine. So this is a diagram to show that here the radius of transition curve is equal to R. R is the radius of curve. As soon as the transition curve is the radius of transition curve reaches R, the horizontal curve starts. Fine. Next is, for transition curve, following types of curves are available. See, different types of gradually changing slopes of curves are available. One is spiral, one is lemniscate, and one is cubic parabola. So here we have shown all the diagrams. Here this is x direction and this is y. As the vehicle starts moving from here to here, these are basically mathematically drawn curves. The one drawn in the red is, let me show one by one. This is a spiral curve. Spiral looks like this, and this is the cubic parabola, and this one is lemniscate parabola, lemniscate curve. So for very small angle, if we observe for this small deflection, the curves are almost equal to each other. The change in angle is almost same for each of the curve. So any curve we use is ideal, but there are some drawbacks for lemniscated cubic parabola, and spiral is used. Will I'll explain it in the coming portion. For small deflection angle less than 4 degree or maybe 4 degree, all curves follow same path and are almost same up to 90 degrees, right? They are approximately in this direction only because they are parallel to x. So for all curves, as the radius decreases and LTC increases, that is, this is representing the length of transition curve. As the radius decreases, the length of transition curve increases. This has also been explained in the this portion. But for lemniscate and cubic parabola, rate of change of centrifugal force is not constant. Hence, they are rejected. The reason for rejection is centrifugal force increases as the radius varies along the curve, and that is why there is different centrifugal force along the whole curve. That is uh, causing that causes discomfort to the passenger and hence is not preferred. Next, spiral curve is hence adopted as an ideal transition curve. So out of these three curves, we use spiral parabola, spiral curve, right? Next is length of transition curve. How length of transition curve is decided? Length of transition curve is based on three types of conditions. One is the rate of change of centrifugal acceleration or centrifugal force. Next is the rate of rotation of pavement if it is done on inner edge or it is done on the center line of the road. Then that also decides the length of the transition curve required. Next is some provisions of empirical relations between length of curve and R, radius of horizontal curve has been provided by IRC. So those are also taken into consideration, and the maximum value of this of the transition curve uh, calculated from all the three values is chosen as the length of transition curve. So first one is the rate of change of acceleration. Rate of change of acceleration, it is given by C delta A upon T. What this means is if the acceleration at a one point is 0 and at a second point it is v square upon rc, right? So the rate of change of acceleration over the time t is given by c. This value minus this value is equal to rate of change of acceleration. Acceleration is basically in meter per second square, and when it is divided by t, it gives, or we can say it is given a second. Meter per second square when divided by second, it gives us meter per second cube, or we can say change in acceleration meter per second square per second, change in acceleration per second. So AF minus A1 v square upon RC minus 0 divided by T. T can also be given as length of curve divided by V, where V is the design speed of vehicle, right? So here we can get V square upon RC. Let me write it once again. V square upon RC into LC into V. It will be converted into VQ upon RCLC, where V is the value of design speed in meter per second. We need to convert it into kilometer per second. Sorry, this is the value in kilometer per hour. We need to convert it into meter per second. We will multiply it by 0.278, and here we can input the value of design speed in kilometer per hour as it is. So we will find out that when we cube this, we will find the value of 0.0215 and RC into LC. Here this whole value is equal to C. Here we have not written. C is equal to this. C is also equal to this. So this equation gets transformed to this value LC goes into this side and C comes on to this side by cross multiplication. So we get the value of 0.0215 V cube upon C multiplied by R. C is the rate of change of acceleration. C is also limited by the value it can have. It can have value of 0.52. This is less than equal to 0.8 meter per second square, where C is also given by 80 upon 75 plus V, where V is in kilometer per hour, right? The maximum allowable value of C without causing discomfort to the vehicle or passenger is given by 80 upon 75 plus V, and C is limited to 0.5 and 0.8. If the value of C comes to be less than 0.5 and 0 and greater than 0.8, we take the value of C is equal to the nearby value. If, let us assume, if in some scenario C comes out to be 0.85, will not take that value and will take the value of C is equal to 0.8. If it comes out to be, this is the first case, this is the second case, if C comes out to be 0.46, we'll take the C value as equal to 0.5, right? Next is the rate of introduction of super elevation. See, I have drawn this diagram. I don't know how beautiful it is or you are able to understand something or not, but let me explain it. First of all, this would be the road coming from one direction. It would be in this way, and it will be going into this direction, opposite direction. So as the rate of introduction of super elevation is, what we are trying to say is, as the road moves from straight section to transition to horizontal curved section, the rate increases from the value of this introduction of super elevation starts from this point. So n, it is represented by n in the figure. This value is equal to n, the rate of introduction of super elevation. Here different that has been shown, different cross sections of road has been shown. This cross section, as shown in the previous diagram, this this cross section is showing the outside edge has been moved to a horizontal position and center line is used as the point of rotation for pavement. Here also the rotation of outer edge has been raised from this to this value and the road is in straight position now. After that, whole road is rotated from this position to this position, right? The angle for this is equal to camber and this is equal to super elevation angle of super elevation, right? So here what we need to find out is how much can be the value of n. The rate of introduction of super elevation is also limited by, as per IRC, it can be having a value of 1 into 115 plain and rolling terrain, 1 into 100 for built up area and 1 into 60 for mountainous or steep terrain. This point represents the start of transition curve. This point represents the start of horizontal curve and end of transition curve. So total length would be equal to this. This would be equal to, so let me explain these values first. So rate of introduction of super elevation is given by 1 vertical into n horizontal. This value is representing the n. 1 is the elevation and n is the length of transition curve. These values I have explained that 1 is to 150, 1 into 100 and 1 is to 60 is provided for rolling built up area and mountainous steep terrain. Now length of transition curve is equal to n into x. This value of x. This is the value of x that we have to find out. So x is the elevation of the outer edge from this point to this. Rotation about the center line. If we take this cross section and we try to have a look at this, we'll find out that tan theta is representing x upon w plus we by 2. Tan theta we have taken equal to small e, that is the angle of super elevation. We have explained that e is equal to tan theta if theta is very small. Fine. So x, that is length of transition curve, would be equal to EW plus WE by 2, and length of transition curve is given by capital N as taken from these values, and EW plus WE by 2, which is this value. And when it is rotated about the inner edge, whole E is provided, then this 1 by 2 is forgotten, and this is equal to NE. Next is, as per the IRC recommendations, it has provided empirical relation for two of the terrains. One is rolling terrain and one is mountainous or steep terrain. When it is plain or rolling terrain, the length of transition curve is given by 2.7 V square upon R, and when it is for mountainous terrain, it is given by V square upon R. Here V is equal to kilometer per hour. It is given in kilometer per hour, and R is in meter. Since it is an empirical relation, we have to take values as given by the code only. So kmph is V is to be taken as kmph, and R is to be taken as meter, right? So the length of transition curve for out of all these values is calculated, and the maximum value of length of transition curve is find out, right? So these were all the discussions that we need to do about transition curve. So for this video, I'm thankful that you have watched this much. So please like, comment, and please subscribe to the channel. I've been writing the value spelling of subscribe wrong many times, so this is the right spelling. So please subscribe. It greatly helps the channel. Thank you. It motivates me to create more such videos. In the next video, we'll be having a look at the numerical portion of this. So for that, till that, thank you. Have a good day. Take care.